Continuing from the previous example, we had the treasury, we call the treasury bond, that the 6 3/8 coupon with the 5% yield to maturity. Now we're going to assume that that bond has a yield to maturity. I don't like the word required yield. I think yield to maturity is the appropriate way to address the yield. Professionals will also use the word yield. So the how does the price change? The price is now 31. The $31 87.5 cents that divided by our 0.11 or 11% yield to maturity. We divide that by 2. We multiply that by 1 minus 1 divided by 1 plus 0.11 divided by 2, and then again to the 10th power, and then our base value is divided by 1 plus, again this is 0.11 divided by 2 to the 10th power. So our price dropped from $1,061 to $825.69. This is it represents the inverse relationships between interest rates or yields and the price of the bond. If yields go up, investors' required returns go up, the price of those bonds is going to go down. So the example, yield maturity and bond value. If the discount rate or yield to maturity is equal to the coupon on the bond, then we're going to be priced at par. If it's greater than, we're going to be priced below bond. That's a premium bond. Price below par, that's a discount bond. If the yield is below the coupon rate, then the price is going to be above par. That's a premium bond. So below this line is a discount bond, and above this line is a premium bond. Important concepts. So, I mentioned this previously, bond prices and interest rates move in opposite directions. So when the rate, the coupon rate equals the yield to maturity, the price is equal to par. If the coupon rate is greater than the yield to maturity, the price is going to be greater than the par value or premium bond. And conversely, when the coupon rate is less than the yield to maturity, the price is going to be less than the par value. That's a discount bond. Next, interest rate risk. So we have price risk, which is what we've been talking about, change in price due to changes in interest rates. Long-term bonds have more price risk than shorter-term bonds. Low coupon bonds have more price risk than high coupon bonds. So that's because there aren't any interim cash flows. Well, in a little bit, we'll talk about zero coupon bonds. Zero coupon bonds have the greatest price risk. Reinvestment risk. The reinvestment risk is uncertainty concerning rates at which the cash flows can be reinvested. One thing to note about the bond price calculation, it implicitly assumes that you can reinvest at that rate, which not necessarily a realistic assumption, but it's necessary for the calculation. So short-term bonds have more reinvestment risk than long-term bonds. High coupon bonds have more reinvestment risk than low coupon bonds because the coupon payments are greater. So bond maturity and price volatility. We've got two identical bonds. The one is a long maturity, one is a short maturity. So the price volatility we can see is going to be much greater. The value of the bond is going to be much more responsive to changes in interest rates. The short maturity bond is not going to, the price is not going to change as much. But if they both have the same coupon and the coupon and the yield are the same, then they would trade at par. So coupon rates and prices. So we have two identical bonds, but except for one's a low coupon, one's a high coupon. The low coupon bond is going to have more volatility, more price volatility as a result of the changes in the discount rate. That's because there aren't any, their cash flows are smaller in between now and maturity. A high coupon bond is going to have large cash flows between now and maturity versus a low coupon bond. So, computing yield to maturity. Yield to maturity is the rate implied by the current bond price, the investor's required rate of return. Finding the yield to maturity would require trial and error if you don't have a financial calculator. But we do have a financial calculator, and it gives us two different ways to calculate yield. One is using the time value of money keys. One thing to note: the time value of money keys are only valuable in calculating the value of a bond on an interest payment date. To calculate the price of a bond on any other date other than the interest payment date, you need to use either Excel or the bond price function on your calculator. If you have a financial calculator, you're going to enter the PV, payment, future value. The PV is always going to be negative. The simplest way to address this, and then you would hit, in this case, you would hit compute IY. The first example here is with annual coupons. So, a 10% bond with an annual coupon rate and 15 years to maturity and a par value of 1,000. Current price would be the current price is $928.09. So the yield more or less than 10%. It's greater than 10% because our price is below par. So in our calculator, N would be 15, PV negative 928.09, future value 1,000, payment $100, and then we compute IY. That's 11%. So next example, we'll start with an example with semi-annual coupons.